So today, just going through the process if we want to graph sinusoids, and we'll do 3 examples. Whenever you do these, and you don't need to copy all these words down, starting place is 3 dotted lines. Use a straight edge. Use the edge of your calculator case, use the edge of your notebook, something else, but 3 straight dotted lines that are equally spaced. Also, 5 tick marks on the middle one, but you're going to leave some room here on the left because sometimes you need to extend going back to the left and sometimes you don't, but we want to leave room in case we need to. When you draw these, this spacing needs to be the same all the way across. You don't have 2 of them close together and then the next 2 spread far apart. That's what you draw first on every single one before you do anything else. Then you are going to identify plus or minus, sine or cosine, and draw the appropriate graph in along those 5 tick marks. Before we are finished, we have to label all 5 of those angles, sometimes more. I call those critical angles because they are either center lines, maxes, or mins. We also need to label the axes, or label the max, min, and center. And both of the axes. And that's all we have to do on these things. So let's jump over to an example. So if we want to graph y equals the sine of 2x, the first thing we do is we draw our 3 dotted lines, and this one isn't letting me ungroup for some weird reason. Pretend that middle one for now is still a dotted line as you draw yours. Leave a little bit of room over to the left. Do 5 tick marks with your spacing consistent. Then look at that. Is this one a plus or minus sine or cosine graph? That's an easy question. Every hand should be at Marielle. Plus sine graphs. And when we do plus sine graphs, where do they normally start? At the center, and which way do they go? So we start, the first tick mark, we start at the center, and we go up. So above the next tick mark, we're at the max. On the next tick mark, we're at the center line. At the next tick mark on the min, and the next tick mark, we're back to the center. And let's go ahead and draw our shape in. I'll say this more than once today. Sinusoid graphs are different from every other kind of graph. You draw the graph first, and then we're going to make the numbers fit the graph. When we've been graphing other things on problem sets, I give you the grid and we decide, oh, we're using the scale, each box is 1, or we're changing the scale, but we know where the numbers go first. And then we plot points and we make the graph fit the numbers. Sinusoids, we're going to do the graph first and then put the numbers in where they fit, because I only want the critical angles. I don't want other degrees that aren't maxes, mins, or center lines. Okay, then let's go ahead with this one and let's decide center line, max, and min. So for this one, what is the center line, everybody? And the amplitude. So the max is, and the min is. Okay, now that we know the center line is the x-axis, go ahead and draw a solid line over your dotted line so that now yours looks like what I have up there. Do we have a horizontal shift or a period change or both on this one? What do we have on this one, Ada? We have only a period change, and how do you know that? There's a 2 in front of the x. So what do I do with that number? Does anybody remember how I take that and figure out what the period on the graph is going to need to be, Hyundai? Divided by that number, the period coefficient in the equation. So you guys want to do this degrees or radians? Okay, I heard more degrees. So what's normal for degrees? And what's the P in the equation again? That means my period needs to be how many degrees? 180 degrees. Okay, now I don't really want this on my graph, so I'm kind of going to do it down here. That means from this starting center line point till I've done a complete period, that has to be 180 degrees, right? That's from that center line increasing to the next center line increasing has to be 180 degrees. You said there was no horizontal shift, right? So this is still 0, and this has to be 180 degrees away. So Eli, what goes in the middle? So we put a 90 on the one in the middle. And what's right halfway between the 0 and the 90, Ricky? Between the 0 and the 90 is 45. That means this space is 45 degrees. This space is 45 degrees. This one is 45 degrees. So everybody, 90 plus 45 is? Plus 45, is that 180? So we have those in there. That spacing is the same. And I wouldn't really leave that on my final graph, so I'm going to erase that stuff and get it out of the way. So do you see how we got those angles in there? Okay, so I've got my 3 lines. I've got max, min, and center line labeled. I've got my critical angles, and that means for those 5 in a row, all 5 of them, not just the maxes, not just the center lines, all 5 of them need angles labeled on them. And so that's why I've got the 0, 45 up to 180. I still need my axes in there. I've already drawn in the horizontal one, but I need to label it. And let's see, this had an X in the equation. So I need to label this X. And I need to put the Y-axis in. And it needs to go on 0. So it goes there. We did not have a horizontal shift. So my Y-axis goes right there. I do not have to extend this one to the left because I need to make sure I have either 0 or something negative, so I know exactly where that y-axis goes. And this one I was okay with that. I didn't need the extra space to the left. Okay, second of the 3 examples. Start with your 3 dotted horizontal lines that are pretty much evenly spaced. On the middle one, leave some space to the left and do 5 tick marks, and be sure that if you measured with a ruler, those would be about the same between each of those 5 tick marks. That is always how we are going to start sinusoid graphs. 3 dotted lines, room on the left, 5 tick marks. Now we look at this and we decide, is this plus or minus sine or cosine? Sonia. It is a minus sine graph. And where does a minus sine graph start and where does it go? Starting from where? Starting from the center and going down, not starting from a max and going down is what so we start at the center and then we go down. So that next tick mark is a min, the next one is back to center, the next one is a max, the next one is back to center, and we draw in our shape right side up U, upside down U, and I'll worry about arrows on the end of that when I'm done. Have I had a period change or a horizontal shift or both on this one? Francis, what do you think? Period change, horizontal shift, or both? And period change or not? Nope, because this is a 1 right here. So we've only had a horizontal shift. This one is in degrees. What is a normal period for degrees? 360. So what that means is whatever the starting point is here, up to here, is still 360 degrees long. However, am I shifting to the left or to the right? To the left. So instead of that first point being at 0, we're moving it to the left. It's now at negative 30, right? So I'm going to make my numbers fit this graph, and I'm going to put a negative 30 degrees on here. Okay, this is scratch work that I'll cross out or I'll erase. If I didn't have the shift, I would have gone from 0 to 360. Middle of that would have been 180. Middle of that would be 90. Everything's 90 apart, so I would have had 0, 90, 180, and 270. If I move the 90 also to the left 30, it is 60 degrees. If I move the 180 to the left 30, so I subtract 30, it is 150 degrees. 270, move it to where? 240, because I move it to the left 30 degrees. If I move 360, where does it go, Austin? 330. So I took each of these and I subtracted 30 to move them to the left and figure out where they are. A lot of students like to do it like that. Think of each one, what would it have been? Move it to the left 30 or subtract 30, what do we have? Other students like to take and figure out, okay, the first one is now negative 30. These were 90 apart. When I shift it, and I didn't change the period, they're still 90 apart. So some students like to say negative 30 plus 90 is 60. 60 plus 90 is 150 for the next one. 150 plus 90 is 240. Plus 90 is 330. Either way gets you there. If you do this as scratch work, either erase it or put one nice neat X through it so I know not to grade those numbers. Be sure your graph has at least 5 of these, every single one of them labeled. And I don't want to know where 45 degrees is, for example. I don't want to know things in between if they aren't maxes, mins, or center lines. But I want those 5 in a row that are. Okay, what is the center line for this one, everybody? What is the amplitude? So what's the max? What is the min? Okay, let's get our axes in. The x-axis is the line where y equals 0, right? Above it is positive and below it is negative when we do any graph. So I need to put this axis in where it switches from negative to positive. Not on the -1, not on the +4, but in between. And in this case, closer to -1 than to +4. So I'm going to say about there. I'm going to do the same thing with the y-axis. It needs to go where x is 0. So to the left is negative, to the right is positive. So it no longer goes through that center line decreasing point. That is now -30. That is not 0. It does not go through 60. It goes in between, and 0 would be closer to -30 than to +60. So I'm going to say about there. Then I need to label. In the equation, I had y and x, so I label y and x, and I need arrows on both ends of my sinusoid that the pattern keeps on going. I had a negative angle and a positive angle, so I was able to figure out where to put the y-axis. I don't need any extra things on the left to figure out where the y-axis goes. Good with that. Okay, one last one. Draw your 3 dotted horizontal lines. Draw your 5 tick marks and leave yourself a little bit of room to the left. Is this one plus or minus sine or cosine? Minus cosine. Henry, where do I start a minus cosine graph normally? Min. So at the first tick mark, I do a dot for the min. That means center line for the next one, max for the next one, center line after that, and then min, and draw in our shape. And does this one have a period change, a horizontal shift, or both? Henry? It has both. So what do we have to do as we start to figure out how to draw this stuff? We didn't really do this yesterday, but I mentioned this as something to watch out for and be careful about. Marielle? Yeah, if I have that number inside the parentheses before I can tell anything about the shift, I have to factor it out. So let's say that this is 1 minus 3 cosine 2/3, factor that out, theta minus something. So let's see, I need 2/3 times what is pi over 6. So when I distribute, I get back to that pi over 6 thing. So let's see, I can't really do that one in my head, but if I multiply that by 3/2 on both sides, I'll have the what? And so that means I would have pi over 4. Is that right? Except you can't tell that's a minus sign there, the way those just ran together. So let me try writing that again. Maybe if I go skinnier. Minus pi over 4. So if I distribute, I get the 2/3 theta, and then I have 2 pi over 12, and yes, that simplifies to pi over 6. So are we good with that? Okay, we want to always figure out and work with the period change before the shift when we're doing the graph. So period change, then the shift when we start putting things on the graph. So that 2/3, and this one has to be radians because we had the pi over 6 with no degree sign. So we know that the period on this graph needs to be normal over that 2/3, right? What's normal for radians, everybody? So this needs to be 2 pi divided by the fraction 2/3. And if you divide by a fraction, you flip it and multiply. So dividing by 2/3 is the same as multiplying by 3/2. So that means my period on the graph needs to be 3 pi. Are we good with that much? Okay, I'm going to shift, so I don't want to start putting those numbers on my real graph yet. So I'm going to do a little bit of scratch work where I can erase it or cross it out. If I didn't have the shift, I would have gone from 0 to 3 pi. So right in the middle of that would have been 3 pi over 2. And I'm not going to do 1.5 pi because that's not how we talk about the unit circle. We talk about 3 pi over 2, not 1.5 pi. And then if I go halfway in between that, this would be 3 pi over 4. And this one I could either say the average of 3 pi over 2 and 6 pi over 2 is what, 9 pi over, let's see, 6 pi over 2, 9 pi over 2 times 9 pi over 4. Did I do that right? Or I could say plus 3 pi over 4 plus 3 pi over 4, 6 pi over 4 is 3 pi over 2, plus 3 pi over 4 is 9 pi over 4, plus 3 pi over 4 is 12 pi over 4, or 3 pi. So these would have been my numbers if I didn't have a shift. But I do have a shift. Which way am I going this time with the theta minus pi over 4? Everybody point. Which way? We need to go to the right. So this one is no longer at 0. It had to go to the right. It is now at pi over 4. We figure out the other 4 one of two ways. We can either say this one had to go to the right pi over 4, so this one goes to the right pi over 4 and is now at pi. This one goes to the right pi over 4 and is now 7 pi over 4. Did I do that one right? And this one goes to the right pi over 4. 10 pi over 4 is 5 pi over 2. And this one goes to the right pi over 4 and is now 13 pi over 4. Or you figure out the first one is pi over 4, and you figure out these were all, before we did any shift, we had 0, and then we had 3 pi over 4, so they are all 3 pi over 4 apart. Pi over 4 plus 3 pi over 4 is pi. plus 3 pi over 4 is 7 pi over 4, plus 3 pi over 4 is 5 pi over 2, plus 3 pi over 4 is 13 pi over 4. So we figured out the real ones and put them on the graph. All this other stuff was scratch work. Okay, let's do our center line, max and min. What's the center line here, everybody? What's the amplitude? So what's the max and the min? Let's put our horizontal axis in. Again, it splits the positives and negatives. It does not go on -2. It does not go on +1. It goes in between, closer to the 1 than to the -2. Let's try to put our y-axis in. But this is pi over 4. Well, 0's somewhere over here. Is it here or here or here or here? I'm not sure where it needs to go. That's why I needed that room on the left. So I'm going to add another tick mark. I need to keep my spacing the same. This is how far apart my tick marks were before. Same spacing, measure that same distance to the left and do a new tick mark. Make the sinusoid go through that new tick mark. And let's figure out the radians for that one. We said these are all 3 pi over 4 apart. So if this is pi over 4, I need to go 3 pi over 4 back to the left. So what is pi over 4 minus 3 pi over 4 going to be? Minus pi over 2, so I label this tick mark minus pi over 2. Notice these aren't plus and minuses of each other. They aren't opposites. I don't have plus and minus pi over 4. I don't have plus and minus pi over 2. I had to think about the spacing. But now by adding that 6th tick mark, I have positives and negatives. So now I can figure out where to put this one between the negative and the positive. And it would be closer to pi over 4 than to minus pi over 2. And I just have to label my axes to match what is in the equation, y and theta. And those go on the axes, not on the center line or the max or the min. And then let's either erase or cross out our scratch work so that it's easy for somebody to read what the real graph looks like. And again, all of these maxes and mins are labeled, not just the maxes and mins. The center lines are also labeled in there. We drew the graph and then we made the numbers fit it. Anybody with questions? Right, then that